Ciao a tutti! So yesterday I received a package containing a piece that I ordered for my wife's road bike. This piece is a carbon fiber clamp for the front derailleur, and I ordered this because I wanted to substitute the Shimano one she had, which is this piece here. As you can see, this is a really chunky boy. This piece here weighs in at around 30 grams. While the new one is much lighter. We are talking about 7 grams. So my idea for this video is to show you how I intend to fix the issue with the new front derailleur carbon fiber clamp using a custom-made 3D print. Yesterday, when I tried to mount this on the bike, I encountered an issue, because probably what makes this part so interesting is also one of its major problems. So the fact that this piece flexes.
Look at me, I'm so light, you chunky old piece of metal.
Not in that way. So what I noticed yesterday is that when tightening in the bolt, I marked the carbon fiber, I scratched this a little bit, and this is a little flaw in the way the piece is intended to be mounted on my wife's specific bike, which has a diameter which is a little bit bigger than the diameter of the clamp. But let me show you first how these two different clamps mount to the bike so that I can better explain myself in what's the actual issue and what are the differences between these parts. So probably the reason why the Shimano one worked okay is because this piece here where the front derailleur is going to attach is totally solid, while the carbon fiber one, as I told you before, has a lower diameter compared to the frame of the bike. So where the front derailleur is going to be mounted, there's a little gap in between, which is making the clamp itself twist, and that is not allowing the bolt to go into the hole in a straight manner, which also means that the clamp itself is flexing and it's going to absorb a lot of mechanical stress. So what's the plan to 3D model a specific part to fix the issue with this clamp? Well, since I'm a programmer, I found myself really comfortable by using OpenSCAD, which is a CAD software to design 3D models using code. And it's actually surprisingly simple to use, I have to say. You don't need to be a programmer in order to use that. And I think this is a perfect scenario to showcase how simple it actually is to use that tool, and also to export the model in a STL format that is going to be sent through the 3D slicer and then right into the 3D printer itself. So I'm going to show you the process. So once we open OpenSCAD, we have a few 3D primitives at our disposal. For example, the cube, the cylinder, the sphere, and we can compose these primitives by using the Boolean operations, meaning that you can add these 3D primitives together, you can subtract those, and you can also intersect them. By doing this, you can achieve even complex 3D models. So we need to decide which primitives to use in which way to obtain our desired results. And for this specific clamp, what I'm going to use is the cylinders, because as you can see, the clamp itself is mainly an hollowed out cylinder, and later on I'm going to perfect the 3D model by smoothing out some of the edges in order to make sure that there will be no issue when using the part inside the clamp. The idea here is to build something like a spacer that will go inside the gap of the clamp itself and allow the bolt to go through and to push against the spacer instead of bending the clamp. The idea in this case is that by filling in the gap, we will be able to tighten in a better way the front derailleur of the bike, and by doing this we will not apply any mechanical stress to the clamp itself, which is going to to break it. We are definitely going over the 3 Newton meters of torque. Once we are done building our 3D model, we can export that in STL format and bring that in Cura, which is the 3D slicer that I'm using, and this will allow us to prepare the 3D model before sending that to the 3D printer. And once we are ready, we can store the G-code file onto a USB and then plug that into the 3D printer and finally launch the 3D print itself. So here it is, the first print of the 3D model is finally completed. Aesthetically speaking, the print is not perfect, but I had to use supports. Anyway, this specific part is not meant to be beautiful, we just need to use this as a spacer. However, the 3D model is not really perfect compared to the radiuses of the clamp, so I will need to give this another iteration. Okay, so even the second print is now completed. The part looks much better than before, actually, even if the supports were used even this time. And the radiuses are spot on, I have to say, as you can see from the image. And yeah, let's crack on and install this little spacer. Yeah, success! The installation is finally completed and I hope you enjoyed. Thank you for staying with me up until the end. If you like the video, subscribe to the channel. Probably I will release more videos like this, and comment if you noticed something that you didn't really quite understand, if there's something that I can improve, some other iterations on the 3D model maybe. Tell me in the comments, and alla prossima. Ciao!